Hi, I'm Vinita. My teammates are Nishita, Raji, and Shravanti. Now I'm going to present a long-end project of Principles of Data Science. Our project name is Customer Segmentation. The customer segmentation is the process by which you divide your customers into segments based on common characteristics such as demographic or behaviors, so you can market to those customers more effectively. These customer segmentation groups can also be used to being discussions of building a marketing. The data including customers from different countries is taken and pre-processed, segmented into the various groups using clustering algorithms. In this, initially the dataset includes 5,41,909 entities. In this, we are going to clean the data, and the null values are removed. Data integrity is verified, data is enriched, and the outliers are detected. The distribution of data is understood and analyzed through visualizations. A clustering model is developed to cluster the customers into various groups based on their purchases. And the initial data set consists of 5,41,909 entries with 8 attributes. Now this is the glimpse of the data distribution, and the first 5 rows of data are extracted to see what the range of the data lies in. Now we are going to clean the data. The first step is to check the null values, and the null values are removed. Initially, the customer ID is in float data type. The ID is in int in the real time, so it is converted into int data type.
Quantity and unit price volume plots are plotted to see how the data is spread. A dynamic location map is plotted to see how many number of purchases are done in each country, and the color indicates the number of purchases. We see that most of the data is from 2011, 93% of data. And when we plot the number of purchases in each month, in the November there are more purchases, and in December there are less. And even though there is more data for the year 2011, but the distribution of data is same when we see the statistical measures. And the mean purchases in both quantity and unit price in each month is plotted, and we see that less number of quantity and unit price purchases are done in November, but the purchases are more, and vice versa. To see more how many which description words are more purchased, the first 15 purchased words are plotted, in which vintage, heart, red cake are one of them. And the pair plot and correlation are plotted, where we see that most of the correlation coefficients are negative and in between minus 0.1 and 0.1. So there is a weak correlation between every variables.
In the stage before clustering, we are applying dimensionality reduction. If higher the number of features, it is harder to work on it. So here we are reducing the number of variables. This is the 3D projection of data in the reduced dimension, which includes the data of customer ID, quantity, and unit price. For clustering, it is important to make the data types to be in numerical labels or categorical labels. So here description and country labels are changed from object data type to int data type. And this is the glimpse after the dimensionality reduction of data, which includes the data of customer ID, description, country, quantity, price. Here we are using k-means clustering algorithm. It calculates the distance between each data point and a centroid to assign it to a cluster. Here we are taking 4 number of clusters. Cluster center is the average of all points belongs to the cluster. Here we are checking the Silhouette score for clusters. Silhouette score is the measure of how similar an object is to its own cluster compared to other clusters. For cluster 6 we are getting the optimal score 0.318, which is near to 1 when compared to the other clusters. And this is the count of unique values in each cluster. This is the code for principal component analysis. PCA is to verify the quality of separation of various groups. And this is the representation of the amount of variance by each component. Cumulative explained variance shows the accumulation of variance for each principal component number. The individual explained variance specifies the variance of each principal component. And this is the plot for the contents of clusters via PCA. And my friend Nishita will conclude the remaining project.
DB-scan clustering is density-based clustering, where it automatically separates the outliers, and where we need not mention the number of clusters to be formed. Here -1 indicates the outliers, and in the data is taken, visualized, integrity is verified, and different cluster models are used, and some scores like Silhouette score is used for accuracy measurement, and DB-scan cluster is used. In the future, we can change the outlier treatment, like we can use mean, median for replacement, and the parameters can be switched or randomly taken, and moreover we can perform with different clusters other than K-means and DB-scan. Now let me quickly walk you through the code. First, I imported the libraries NumPy and Pandas, imported the dataset and checked the data types, description, number of rows, columns, and checked for the null values and removed them, and converted some like customer ID to int, and extracted the date and month from the invoice, date, timestamp, and remove the outliers and check the value counts in each attribute, and detected the outliers using the bots plots, and remove the and treated the outliers by setting some threshold values, and then plotted Violin plots and location plots, pie charts, and then found some distributions of data through statistical measures, and for the frequency of words is found using frequency array, and pair plot heat maps are plotted, and label encoding is done to change the string variables into integers, and the Silhouette score is calculated, and using the two clustering methods the customers are segmented.